Some people think that natural selection might explain microevolution, but it can't explain macroevolution. Before we break down the ins and outs of why this is incorrect, let's figure out what all these big words mean. Natural selection is one of the driving forces of evolution and is based on 4 ideas: variability, heritability, differential fitness, and non-randomness. Individuals in a population differ, causing some individuals to survive better or worse. Individuals that survive better have a greater chance of reproduction, allowing their genes to be inherited by more offspring. Over time, this leads to population-wide changes.
Microevolution is the name given to the changes in populations of organisms that can occur over a short time period. This is influenced both by natural selection responding to pressures in the environment and random mechanisms such as mutation and migration. An example of this is the guppy populations found in Trinidad and Tobago, which exhibited differences in time to maturity and reproduction rate based on the level of predation in their environment.
Macroevolution describes large changes in a species over time, such as mammals evolving to live in the sea or dinosaurs becoming able to fly. This process is essentially microevolution over a longer period of time, and is the reason that, with enough changes, new species can arise. Mutation and migration no longer have the same level of impact over such a long time frame.
Now that we know what we're saying, we can figure out how and why this statement is flawed. The main issue is the assumption that microevolution and macroevolution are different. As we described earlier, macroevolution is a similar process to microevolution, but over a length of time great enough to cause major changes.
The key misunderstanding here is that evolution is the result of multiple different processes interacting with each other to cause change. Natural selection is the mechanism by which populations change over time, but only does so in response to environmental pressures strong enough to warrant such a change. Without the other, neither of these effects would cause any kind of evolution. You've probably heard the story of how the T-Rex became the chicken. It might seem impossible that a tiny chicken could be related to an ancient beast, but evolution is a gradual process made up of many small changes, microevolutions. Dinosaurs closely related to the T-Rex adapted feathers, wings, an arboreal lifestyle, and eventually became early birds.
These traits were passed down as they made these species successful, especially after the non-avian dinosaurs went extinct. Each change that was selected for was an example of microevolution, but as dinosaurs underwent more and more alterations, they had gone through macroevolution, and then we have birds. The early birds diverged into the many species that can be found today, including the humble chicken. We can see morphological evidence of this relationship in the structure of bird wings and the pectoral girdle, as the bones have been shown to evolve from the bones found in dinosaurs' arms and chest.
This same process can describe how small land mammals such as the Indohyus would eventually become cetaceans such as dolphins and whales. Their ancestors found more and more success in increasingly aquatic lifestyles, with their limbs and tail adapting into flippers and a nasal opening moving to the top of their head.
The back legs would eventually be entirely lost, but their history can still be observed as a vestigial trait, a pelvic bone that has no function for the modern cetacean. A study found that cetaceans share other genes, such as milk protein and immune system genes, with mammals such as humans, dogs, and mice, which show that they share a common ancestor with terrestrial mammals.
We hope this has cleared up about how natural selection and microevolution are involved with macroevolution, and how all this is supported by genetic and fossil evidence.